Okay, good evening, everybody. Today's talk for Singapore Microcomputer Society is on Greek energy storage. Okay, this probably won't be applicable to all of you, but it is good to know. And then we'll talk a bit on, at the end, we'll cover what our Singapore government should have done for this Greek storage. Okay, first we would like to define or clarify what is Greek energy storage, and then we'll talk about the importance of Greek energy storage and the current technologies, some future potential and technologies. A few are under prototypes, some are only ideas. Then we will open for discussion. Okay, so what is Greek energy storage? So when electrical energy is stored during times when there is excess, and then later it can be returned to the grid. So when there is a demand. Okay. So when would you want to store the energy? You can store energy when you have too much. So for example, you have solar energy in the day, and then if the solar energy is producing too much energy to be used by everybody, then you can store that extra energy. The other option is when the grid or the power stations can provide a certain amount of energy, and then during the low period when the demand is very low, then the power station will be almost running at very, very low capacity. So instead of letting it run at very low capacity, you increase the output a bit, and then you store the excess energy, so that in times of need, you can use this energy to feed back into the grid to supply the excess energy. This is in situation when your power station at maximum capacity cannot meet the peak demand. So if the power station cannot meet the peak demand, then you either build a new power station, or you just store the excess energy during low consumption time. Then you can provide this extra energy out. And this is only during a short period of time, maybe during very peak period when the demand is extraordinarily high. So there's no justification to build another power station just to cater for a very small time period when the demand is exceedingly high, beyond the capacity of all the power stations. So you may want to store the energy during this short period of high demand, so that it can be used during this short period of high demand. But whether you want to store the energy or when you want to store the energy, it all depends on the price, and then the infrastructure and other factors. Mainly price and infrastructure. If the price is no good, nobody will want to store energy and then return back to the grid. You lose money, then who want to do a lose money business? If the more energy you store, the more money you lose, then nobody wants. But if you can store energy cheaply, and then when you sell back to the grid at a higher price, then it's worth it. At least you can get some money back for the effort. Okay, and then the infrastructure also restrict the choice of energy storage. Okay, the Greek electricity, okay, when electricity is not used, then it's gone. it's not like a battery when you can store your energy. So energy is electricity is stored in the form of chemical energy. So chemical energy can be converted to electrical energy, and then your battery will run your phone. But electricity in the grid is the flow of current. There's no way when you cannot just let the electricity go somewhere and then they put all the electricity in a bucket and keep it. It's not like that. Electricity, if it's not flowing, it's not doing any job. Of course, the power station will not use as much gas or oil to produce the electricity. When the demand is low, the electricity production also reduce, then less oil and less gas will be required. So it's not that you use the same amount of oil or gas. However, the energy that is running is not used. That's all. Just like you power a generator and then you don't switch on the light, the generator will just run forever and then it just consume energy. It's just like you keep your car idling. You turn on your car engine and then you don't drive. So the car is not moving, but the engine is still running. You consume energy, electricity, and all this. Okay, so, and there is a problem of insufficient electricity. Okay, when the grid cannot supply enough electricity, then you get brownout. Brownout means you will see your light suddenly dim, and then your computer maybe will shut down, and your power start to drop, and then some of your equipment, the fan will run slower. Then in worst case, the electricity just back up, then you get no electricity because the grid just stop. No electricity, it just shut down. So in Singapore, we had a blackout before. So it's not that it won't happen. So blackout also can be caused by mistakes where somebody broke the cable. Okay, if nobody break your cable, then you shouldn't have blackout. But if your power station is not planned properly, then as factories, offices starts to proliferate, then you have more energy consumption. But your power station cannot supply that amount of energy, especially during peak period when all your power stations add together don't have enough energy, then you run into problem. So there is always this energy planning that you have to go in. So one way is to, as what the government did for the COVID-19, is to flatten the curve. So you don't want everybody to switch on the electricity at the same time. So you want to spread out. So let's say if you have an office, you get the office to work at night instead of daytime, and then or factory to stretch longer period, or whatever you can do lah. So that there's a limit to that, because factories and offices just cannot switch electricity consumption. Okay, so you still have to plan for peak consumption. Okay, the other problem is when there's too much electricity, the grid will also shut down to protect the other grid from being overloaded. So when one grid shut down, then it causes a cascading effect. Everybody will suck energy out from another grid. So you end up one grid has too much energy, shut down, the other grid become not enough energy, electricity, and then they start to shut down. So this type of effect happened before. Okay, and then the other thing is demand cannot be accurately predicted. Of course, sometimes you have special events, then you can predict what's the energy demand is. But most of the time, you can base the demand on the past events, like historical event. But events change. Let's say COVID-19 recover, everybody start to work. Then fewer people will stay at home. More factories will open. Factories will have a backlog or whatever. Then they run longer hours. So the demand will change. So if our grid cannot take in this amount of demand, then the whole system can fail. So one by one, the grid will start to fail, and then we get in trouble. So one way is to flatten the curve, same as COVID-19. Okay. However, the supply itself is more predictable. If you are running a power station on gas and oil, it's predictable because you can control the gas and you can control the oil supply to run the generator. Okay, but of course, if the gas pipe bursts, then you are in trouble. One station down. And if your supply comes from solar energy, more or less you know that you have supply in the day. But the sun can be covered by the cloud, or it can be raining, and then you have less electricity. So these are considered unpredictable because the cloud can move in whatever manner they want. So sometimes you have high, sometimes lower, and so on. So it's not so predictable. And then wind also, if you have wind energy, then the wind also is not predictable. Of course, you can use wave energy, which is more or less predictable because wave is always coming. But if you use a tidal flow, also predictable because you can control the tide, up, down, the tide. But all these things are not very suitable, like tidal energy or the wave energy is not very suitable for Singapore because we are surrounded by islands like Indonesia, Malaysia, Peninsula, and within the Straits of Malacca. So we are very well sheltered, and there is a very little wave or current. Although to you, the current can be very big and strong, but for energy generation, you need very high wave, and you need very high tide. And we are at the equator, the tide is not so much, maybe 1 meter up to at most maybe 2 meter height, that's all. Whereas in some parts of further away from the equator, you can have up to 7 meters or even 14 meters of height, of tidal height. So for us, tidal energy is also not very much, not much to harvest, and we don't have a lot of space to store all the water from the tide. So our energy supply from all these natural sources is not very high. And also wind is not very strong in Singapore because we are near the equator. If you are further away north, then the wind can be stronger. Okay, so here we show you an example. The green line, okay, is, for example, is the generator power, which means, let's say, the demand, the generator power for the power station, the average demand in that sense. So the consumption in the middle of the night, the consumption is low. As it approaches morning, the consumption pick up. Until afternoon, the consumption is there. And then at night, everybody go back home, office start to close, factory close, and then you have fewer factories operating, and then the consumption drop again, and people start to go and sleep. So this is the red line represents the consumption. Okay, so if you have a Greek energy storage during the low period, you can generate the same constant power. That means your power generation is constant, just constantly generating power. So this excess power, the difference, this excess power can be stored. So example, you store this. So during this period of lower consumption in the middle of the night, your generator will generate power and then you can store them. So during the daytime when the demand is high, your generator still produces the same power, but the excess power you can get from your stored energy. Of course, now you ended up with two systems. One is your power generator, the other one is your storage system. So you got to weigh whether you want to build another generator or you want to find a cheaper solution just to store some energy during this period. Of course, if the demand is very high, really very high, then it's worthwhile to have an additional generator. But if let's say one generator in this case can produce 1,500 megawatt, so you got two generators, you end up with 3,000 megawatt, which is quite high. And then your capacity of the generator is 3,000, but your maximum peak is only about 2,000. So you got 1,000 spare, which is not used. So you are actually wasting resources to build a power station. So you will also find that most of the time, one power station is enough. You only need the second power station for short supply. And which power station want to build one that can supply only during the peak? How to earn back the amount? People will want to earn back as much as possible in the shortest period of time. So the cheapest solution is to store the energy and then release it during the peak hour and then store again during the night. Okay. So one of the very common stored energy is using pump hydro. This one has an efficiency of, let's say, 70 to 85%. So this one is they have a storage tank, or you have a lake, or it can be man-made, but man-made lake is very expensive. You can be a natural lake on top of a mountain, or some lake in a high ground, or some empty hole somewhere. So that will become a natural source of storage for your water. So during the daytime, you can pump water in, or during, let's say daytime means, let's say you have solar energy, then the excess solar energy you can store here. Then if you need more energy, you can release the water and then run a turbine. So if you have a low energy requirements demand, then the excess energy, you can run your power station to pump water up to this storage tank. So it's like a dam, but it's not a dam. Has water come from the sky, but this one is water you pump from your bottom, from the ground up. It can be from a sea or from a lake at the lower end. Okay, Singapore don't have a pump hydro because we don't have big lake. Our lake are all on the ground near water level like Macritchie and Seletar. So the other option you can think of is compressed air. Okay, by compressed air, you need a huge space for this Greek storage. You get one cylinder, two cylinder, your compressed air will be enough for a short while only. So in order to have more energy storage, you need a very huge space to store your air. So your compressed air, if you pump your tunnel, you have to make sure the tunnel has no leak. If you pump the air in one side of the tunnel and the air come out naturally from the other end of the tunnel, then it's useless. So you have to check and seal up the tunnel, make sure it is sealed. Of course, you don't have to worry about the tunnel will explode because you pump too much air and then the whole mountain will just explode like a balloon. Because the mountain is so big and so heavy, it's not likely that your air pressure will be large enough to explode the mountain. But if you are storing air inside a tank, a storage tank, then if you pump too much pressure into the tank can explode. So when the tank explodes with a compressed air, it's very dangerous. Okay, but our Singapore government is not likely to use this type of cavern for compressed air. They are more interested in storing more precious items like oil or other things, maybe ammunition and all those things that that they can store underground. Okay. A very common rig storage is batteries. Yeah, this one very famous is this Tesla installed in South Australia. The batteries with 100 megawatt hour capacity. So this battery in time of peak demand or suddenly there's a high demand, then the battery can supply the power instantaneously. So this one will smoothen out the curve, because if you have gas station or you have oil generator, when you want suddenly somebody switch on a high power device, your generator cannot power up immediately. It will take time to rev up the revolution, or pump in the oil to power up the thing. And then for our power is also AC. AC power is not like DC. You cannot make the generator run faster or the frequency get changed. You must maintain it at 50 hertz. So it must be 50 cycles per second. So all you need is to add more power. If the demand is high, then the engine will not turn. The generator will not turn. Then you have to pump in more oil or more gas to force the generator to turn. Otherwise, you get slower and slower. But battery don't have this issue. Battery with electronics, they can quickly fill up the energy demand difference. So you get very, very perfect demand and supply. Now, of course, the cost is very high. When we talk about batteries, we can talk about car batteries. This is an idea that has been floating around. And if you consider each car have 300 kilowatt hour of battery storage, and then you have 10,000 cars, you have 300 megawatt hour. So if all these cars are plugged to the grid, then you can literally have one large battery like the one in South Australia. So, but of course, if you want the car to take part, then you got to pay for the car battery usage. Because if the fella top out his battery from the grid, he got to pay for the energy. And then when he supply the energy back to the grid, you got to pay him back. of course, he must earn some money. Otherwise, he take from the grid, let's say 20 cents, and then you pay him 15 cents, then he lose money. What for? He contribute to your grid. So you pay him 20 cents, he don't make money. But the battery charge, discharge, and charge and discharge again repeatedly, the battery life can be shortened. So of course, you will want to be compensated more for using his car battery to power the grid. So they need to be paid. How they are paid? So far, few people talk about it, but it's not very well implemented. The other thing is you need a very complex infrastructure for so many cars to be plugged to the grid. And for a car to plug to the grid, it's not so straightforward because you need the electronics and you need to make sure the timing, the frequency is the same and in the correct phase. Otherwise, you mess up the whole grid. Instead of you charging the grid, you'll be sucking energy out and so on. And there's other problem. For example, if the grid is down, your car cannot supply energy to the grid. Otherwise, somebody who's trying to repair the grid when it's down will get electric shock because your car is supplying the energy or electricity to the grid, and then you get electric shock because of your supply. So there are a lot of infrastructure, and you have a lot of this mini grid feedback from 10,000 cars. With 10,000 cars, you probably will need like 20,000 or 30,000 grid for them to plug in, because not all cars are plugged in at the same location. So it's a very high cost project. So sometimes the government just don't care, or they don't have the energy to do all this. Other than car batteries, home batteries also can. So if you have a solar panel and you charge your batteries in your house, so when during at night or peak period when there's a demand, then you can supply the energy back to the grid. But this solar panel system of grid as the grid storage is not has a lot of other problem, because the peak demand is normally in the day, and then you have the solar energy. Why would you use the solar energy to charge your battery when you can sell the energy directly to the grid? So you don't need to waste energy charge. And during the night, when the demand is low, your solar is not producing energy. So there's nothing for you. And if you charge your battery during the day, at night, there's no buyer because the demand is low. A lot of power stations, they themselves can supply the energy. They don't need to buy from you unless you use it yourself. So if you use it yourself, then how you supply to the grid? So all these are problems because of people work in different times, and then the demand and supply is not always in sync. And then you have another problem of monitoring who give how much energy, how much to pay, and payment is not a constant amount, like how much energy you give, we pay you how much. It's also during the time. If during the time of high demand, of course your payment will be higher. During the time of low demand, then you won't get paid. You probably got to give free or you don't give. See, in some countries, during the day, the energy is free because the solar produce so much energy that nobody want to use. So you can use it for free also. But in the day, you are not at home, so you won't benefit if you are in the office. But the office will have an advantage, then they can turn on the aircon, they don't need to pay for electricity. So some in Singapore is the other way around. Singapore daytime, the demand is very high. So you got to pay for electricity. At night, when the sun is down, there's no solar, but the demand is also down. So you pay less for the electricity. So you can use this method. When you pay less, you use the cheaper electricity to charge your battery. And then in the day, when it's more expensive, then you use your battery to power your devices. Okay, this different charging scheme is only for commercial factories or offices where the consumption is high and they have a special charging system based on the time. For home user, it's always a flat rate, the whole month. Sometimes they fix the flat rate for the whole year also. You sign a contract for 3 years, they flat rate you for 3 years. So this you don't see this demand and supply payment based system in your home. Okay, flywheel storage has an efficiency of 85%. All these are estimates, and it's basically a very heavy piece of object. Like here, you should spin like hell, spin at very high speed. Okay, so this thing spin at high speed, and when you need the energy, then you power it from the there's a generator here that you can power, you can extract energy, and then the flywheel will slow down. Then when you have excess energy, you just power the motor instead, and then the flywheel will speed up. So it's storing of energy in the flywheel. Okay, this is not very common, but it is used. So there's other issues like resistance. So when there's resistance in spinning and all this, though you will lose energy. So that's why this thing normally run inside a vacuum, so no air resistance. And then they use a magnet so that it will not touch any surface, and then it will spin without any friction. And then there's another problem is when the earth rotates, then you have a problem. This thing will not align with the rotation of the earth. So those are technical issues. But flywheel is one of the options that people can consider because it does not occupy a lot of space, and then it can last very longer than batteries. Because chemical batteries, after a while, the chemical will be corrupted or diluted, and then you won't be able to have as much energy in the battery as previously when it was new. The other way of storage in battery, they call it flow battery. This one also similar, about 80%. So they have a continuous chemical electrolyte flowing in and out. So all the used electrolyte will be taken out, new electrolyte come in. So as long as you keep replenishing all the electrolytes, then your battery will be as good as new. So you can even pack them in a container, and the container, if you open up, these are modules by modules, everything is inside there. So you can ship it out easily in containers. Okay, basically how it works is you have a pump, one pump here, one pump there, one pump, one electrolyte out, in, and then same thing lah. So it's just like replenishing the chemical inside a battery. So once in charging, then you pump the reverse way. So the electrolyte will chemical reaction will be is reversible. Okay, this is another one of the models. There are many models using different type of chemicals under research to see which one is easier to manage, cheaper, safer, and all the reason, every reason. All these electrolyte, they have to test for corrosion, stability of the chemical, and how long the battery can last, and many things. Okay, the other one is a liquid metal battery, which I've already mentioned. So far, there's a lot of talk, but this one is not implemented everywhere yet. Maybe it's still under research. They have some production, very small scale production, and it's not cheap at the moment. So this company like Embryo, this person is Don Sadoway, and this battery operates at 500 degrees C. It's very hot, so all the metal is molten. For example, they use magnesium and antimony. So once you use up, then one of the metal will disappear into the electrolyte, and then when you charge back, then the metal will get back. You get back the metal. So this one can be charged and discharged. And once the temperature drop down too low, everything becomes a solid. Once it's a solid, you cannot operate as a battery, and it's very safe to transport it at room temperature because it's solid. It's not a battery. You will not get short circuit or it will not explode. Okay, for example, in detail, you can slowly look at it and analyze this thing. Charging, discharging. So it's the molten salt. Charging, the magnesium go up. Discharging, the magnesium go down. So you go up and down, up and down. So of course you cannot charge until nothing left. Then it won't work anymore. So there's some control to prevent you from exceeding. So they can also put many modules together into a container, and then they can ship the whole container. Of course, the operation wise is the high temperature that some people find not so nice. But the temperature is not an issue because it is very well insulated. You can touch it, you won't get burned. And then as the battery runs day and night, charge, discharge, the temperature will remain there. So it won't cool down. And it is good that a lot of other batteries, when it's too hot, you must stop using. You cannot use the battery because when it's too hot, the battery will burn, just like your phone battery. If it's too hot, it has to shut down. Otherwise, it will catch fire. So for this type of battery, the hotter the better. So they are not so afraid that the battery become hot. They like it hot. So under research, they're talking about low temperature liquid metal battery, such as like room temperature, using some of the material, gallium and all these things. The other storage that you can consider is liquid nitrogen storage. The liquid nitrogen is a gas like the air. The air is 78% nitrogen. So you can compress the air and then you get the oxygen and nitrogen, basically oxygen, nitrogen with other gas. If you are not so particular about pure oxygen or pure nitrogen, then it is okay. Because for energy storage, you don't care so much whether it's a pure nitrogen or not. And then this type of compression, the technology is there already. So you can just buy this type of compression, this type of cylinder, big cylinder, then just pump in the liquid nitrogen, and then you can store it up. So you can store a lot of energy inside in a small space. If you need to scale up, you can just get another cylinder, and then you pump you cool down the air into liquid, and then you store it. So some call liquid air, or you can call liquid nitrogen. Okay, and then compression, cooling, all these are very mature technology. Okay, and when you do compression, one side is cold, and which is you want to freeze it, because the other side is hot. Just like a refrigerator, inside the fridge is cold, but outside the fridge, those fins at the back, they are hot. Same like air conditioner. Hot air come out, cold air and cold inside your room, hot outside. So the heat, if you can use the heat, which is a byproduct, maybe to heat water. For cold weather, it's okay. Let's say you have a winter, then the heat can be used to heat up the building or for other purpose, so it's useful. In Singapore, the heat is not exactly very useful because we normally use coal. Of course, you can use heat for heated swimming pool, heated water can use for laundry, can use for cooking, whatever. So, but to transport heat from one location to another location is also a problem, and it's a cost on itself. So you may want to consider the heat as a potential energy source, but it's difficult to be exploited. The other byproduct is oxygen. When you cool the air down, one byproduct is oxygen. What you want is nitrogen, but oxygen is the byproduct, which is useful. You can take this oxygen, you can sell it in oxygen tank. It cannot be pure oxygen, but it is quite pure in a sense. It may contain some other products, other gas, but basically it's still considered quite pure. So you can earn money from oxygen, you can earn the money from the heat that you produce, and then you can sell the liquid nitrogen. Nitrogen also can be used in many purposes, like food production, where they store nitrogen inside the packaging, so oxygen don't enter it, and then the food will last longer without oxygen. Okay, so liquid nitrogen, when you want to use it to generate electricity, you just need to heat it up. If you expose to air, then it will absorb heat from the air, and then it will expand. The liquid will expand, become gas. It will become gaseous, and it will expand. The volume will increase, and that will be enough to power your motor. Of course, you can supply heat, then the expansion will be more. But when you supply heat, you are actually consuming more energy. Of course, the heat can be supplied from your own, because when you compress the nitrogen, you have the heat. So this heat, if you store it, you can use the heat to heat up this nitrogen liquid to get gas. You also can get more energy out of it. Okay, and then you can also use, let's say, ambient air to heat up the liquid nitrogen, and then the cold air, the resulting cold air can be used for cooling, either for refrigeration or for building air conditioning, which is quite a useful byproduct lah. Because when you expand, the byproduct is cool air. So this cool air can be used to cool our offices or maybe our cars and so on. So of course, the liquid nitrogen evaporated, become gas. Then the gas drive turbine to produce electricity. So this one, I find this a potential in future cars, because if you have a lot of solar energy, in future you got a lot of solar energy, nothing to do, then use the solar energy to liquefy nitrogen. And if you drive a car, your liquid nitrogen can be used to power your car. At the same time, you can cool your car. So you stay inside, you don't need air conditioning. You don't need energy to produce air conditioning because the byproduct is cold air. So I believe this is a good potential, although it's not popular at this moment. The other one is molten salt. You can store your energy in molten salt. That means you heat it up to melt salt. Salt can be table salt, sodium chloride, or any other salt. Salt means it's a chemical compound. And of course, you have to be careful of corrosion, because salt can corrode metal and so on. So you cannot use a plastic to hold a molten salt because it's very hot. So during high demand, you can use the salt to boil water, and the boiled water, you get steam. The steam can be used to drive the turbine to produce electricity. Then this type occupy very little space. So if, for example, in the daytime, you can store the energy from the solar as a salt. This can be energy from the sun directly hitting the salt to melt it, and then you can store it. Or energy from the sun, and then you drive a heater from solar, or energy from electricity, or whatever energy that comes from somewhere excess, you just heat it. It's just a way to store energy as heat. And when demand is high, then you can use this heat to boil water to drive turbine, produce electricity. So this is one way of storage. Okay, the other storage, a lot of people talk about like gravity storage. Gravity storage must be very huge, very, very big, and very, very, very heavy. And all these are concept only. So far, I haven't seen any real implementation. In this case, when you have excess energy, you pump it into as water, you pump it, and then you raise the whole cylinder up. Because there's energy, there's pressure. As you pump water in, this whole thing will be raised. So when you want electricity, you just release the valve, and then the water flow backwards, and then you can drive your turbine. This is for this pipe. Whichever way go in or go out, it doesn't matter, because water pressure is the same. So you can be only one valve, pump in, pump out, pump in, pump out, or other construction. But that one is very huge. The other one, there is a small little prototype. They use a heavy concrete blocks, each one like 30 tons. So they lift it up and then position it. Then when you need the energy, you just release it, lift it up, and then release to the floor. As you release it, the energy will be given off. The gravitational potential energy will be converted to electrical energy. Okay, but if you look at it, if somebody just pick one block out, then the whole thing will topple already. But of course, it's not so easy because each one is many tons, like 30 tons. So it's not easy to, for one person, like a toy, you just, or like cuts, you just take the bottom piece and then everything collapses. It won't happen. But this type of thing is also very dangerous. You won't want to be under this, because if the placement is not accurate or what, or there's a stress in the structure and then one part collapse, then the entire piece collapse and you are at the bottom, you'll be dead. Flat meat. Okay, if you look at gravitational energy, okay, let's say 1 ton, which is 1000 kg, if you raise this to 100 meters, so how much energy you require is mass times gravity, acceleration due to gravity times the height. So it's 1000 kg times 9.8, which is roughly about 10 times 100 meters. So you got 1 million joules. 1 million joules of energy. That is a watt second. So you convert to watt hour, is 278 watt hour. That's equivalent to 8 power bank. Imagine you have to raise 1 ton of concrete up 100 meters. Is it easier to raise 1 ton of concrete up 100 meters, or is it easier to charge 8 power bank? I think you can carry 8 power bank with you rather than carry 1 ton of concrete at 100 meters. And to raise 1 ton up to 100 meters, your infrastructure, your bone, I mean the frame and the structure to hold 1 ton at 100 meters is a lot. And then if you want to have not just 1 ton, 100 tons, and then it's even bigger. So how much infrastructure required to hold such a massive weight? So it's easier to just get a power bank. If you calculate 1 battery power bank, 10 ampere hour at 3.7 volt, it give you 37 watt hour. So it's roughly about 7.5, 8 power bank. So I don't, in my opinion, gravity energy is quite useless. A lot of people talk about it, but it looks impressive, but I don't think it will work. And it's too heavy. You don't even want your building to be next to it. In case it collapses, then your building also gone. Because these are very heavy blocks, tons of it. And so what's so important about grid storage? Because first, it's very expensive to double, let's say, the number of power stations. If you want to, if your peak demand is double the average energy, then you got to double the number of power stations in order to cater to the peak demand. Yeah, I think you probably understand what I mean. See, just like if you have a class, and then you want to conduct a class, and then sometimes the demand is high, sometimes demand is low. If sometimes you have 100 people, and sometimes you got 10 people, but you want to cater to everybody, then you must have a lecture room that caters to 100 people. So when there's a 98, you still can take it. If there's 101, then one person cannot come in. So there will be insufficient energy for one more person. But if you have 50 or you have 10 most of the time, then your 100 capacity lecture room will be underutilized. So if you are paying for it, would you want to pay 100 capacity or just maybe 20 capacity, and you save the excess money? And then those who cannot turn up, just tell them sorry. The amount of money that you earn less from this sudden peak in demand is enough to cover your savings. I mean, your savings of the rental for the lecture space may be enough, more profitable than the extra income you want to cater for maximum capacity. See? So there's no country in the world that will build number of power stations just to cater for peak demand. They will have to cater for the average demand. And then in peak demand, what they can do is increase costs. So people would say, oh yeah, let's not use it during the peak hour. Let's use the energy during the off-peak hour. So in a way, they flatten the curve. Okay, once you flatten the curve, then your power station can run smoothly to cater for everybody. Okay, then there is a problem with the proliferation of solar energy, and everybody is trying to supply energy using solar energy because it's getting cheaper and cheaper. Installation is getting easier and easier. So another advantage is the energy demand during the day is higher. So solar energy can fetch higher price. And at the same time, you got a bright sunlight. So it's a very good timing. So with bright sunlight, you got more energy, you can sell at a higher cost because the demand is high. So why not? So a lot of people will want to go in and tap the solar energy and supply to the grid. It will come to a point when everybody is supplying energy using solar and during the daytime. And now your supply exceeds demand. Then the last player who come in, you suddenly find that the energy cost or energy price is very low. So his return on investment will take twice as long as he had calculated. So there's this problem already. A lot of countries are facing this problem. Singapore will face this problem, but it's not so apparent because we have very limited space, and our solar panel has never reached a state of where we exceed demand. We have a very little roof space. We don't have a lot of big, huge desert where you can store your solar panel. Install small little installation, considered smaller in industrial stage. At the industrial level, you store on a HDB flat, on 1 block, 2 blocks, 10 blocks, 100 blocks. These are very small. And how much space you have, and your maintenance is also very high. You must make sure your solar panel on the rooftop don't fall down when the wind blows. Sometimes the wind blows, the panel you can lift out all your panel and then throw it onto the ground. But on the desert, if the wind blow and lift up all the panel in the desert, unlikely somebody will get hurt. See, in desert, the space is very big. You can put any number of panels. You can never cover the whole desert. And the rental for the desert is also very cheap. So in Singapore, our solar has not reached that amount of capacity. So the return on investment is still quite high, but very small. So here we show some example. This is your generation capacity. You can produce so much power. Your generator constantly produce so much power, no problem. And then the energy usage, it goes up at night, daytime go high and so on. This is just arbitrary. Okay, so a demand like that. And then what happens if you have a solar energy coming? So you produce solar energy in the day. So you find that your power generation, to meet the demand, you have to generate the power all by yourself. And then when the sun comes out, you can afford to lower your production. So you find that you have excess capacity to cater for peak period. Of course, when the sun didn't shine, then your demand will go up. But this curve will more or less flatten. So initially it appears to be a good sign, because you suddenly find that you don't need to build another power station, because the solar energy actually came in to flatten your curve, your peak demand curve. Okay, but what if more and more solar energy come in? So your solar energy come in, it actually almost meet your demand already, and then you find that you become unwanted already during the day. Nobody want your energy, because your energy come from gas or oil is expensive, so people don't buy from you. I get from the solar energy, it's cheaper. Or a lot of companies, they install solar energy on their rooftop. If you go towards all those companies, they have very big rooftop, and some have a very big land area for their car park. So all those areas they can install solar energy. And if every of these factory demand for solar energy keeps going up, and then the demand for electricity during the day keeps falling, you come to a point when you are under capacity already. During the day, you are actually unwanted. So as a power generator, you find that your profit drop, because during the daytime you can earn more because the demand is high. So demand high, you actually charge more. But now the solar panel come in and eat into your pie. Your energy demand from your power station is not there, and then your profit goes down. Profit goes down, then who will want to invest? Then this method, I sell away the power generator. Before I keep the power station. I mean, this could be one of the reasons why Singapore get rid of all the power station, because they can foresee that in the future, all these power generating company will face all this type of problem. If the government is going to promote solar energy, then all the power generator will have this problem. But if the government is operating the generator, then the government will not promote solar energy, because it will eat into its own profit. So there is a conflict of interest here. So it's best you don't hold the power station. Then you just concentrate on the solar, you promote everybody, all the investors to invest in solar energy. But then those who generate electricity using oil or gas, the nasabo, so they will change the formula. They will charge more for night use, because at night the solar energy is not competing. The sun is down, there's no solar energy. They are not in competition with the power generator. So the power generator can afford to charge more. So at night the prices may rise a bit. Daytime the prices will drop a bit. So this is a problem. And then you will find that if the sun stops shining, then the power generator will have to boost up. But to boost up the power is a problem, because you cannot turn the turbine instantaneously up and down. All this, you cannot adjust the power immediately so fast. But the crowd come and go, and then you have to have energy to supply during this period. Sudden crowd cover, the passing crowd, and then you must have a energy to supply, and this is the energy that you need from the storage. So the energy storage is very important in the future. In fact, it is very important now that we are moving forward. Okay, so here in conclusion, Okay, we would like to say that power station will lose money because this solar energy is disrupting their formula already, and they are not operating continuously. So they are not operating in a continuous generation energy production. Means sometimes higher, sometimes lower, and this is not very good for their business. See, and then when there's no sun, then you ask the power station, hey, supply me the power now. I need the power now. He said, we wait long, half an hour. Then half an hour the sun come already. Then the power, hey, no, I don't need already. Then okay, you wait long. I need time to slow down. So you have all these problems. So you need instant response to sudden peak demand and so on. So battery is one of the solutions, and it is one of the most expensive solutions. And battery has a lifespan. So now is how the government is going to handle all this power will mean whether in the near future you get brown out or blackout, okay, or you get a nice power. If your country has poor power management, then businesses may not want to come here, because as and when they do some work and then there's a power failure, or you type a long letter and then suddenly power failure, then you lose your content, or your computer shut down suddenly, then you got lost cluster, this and that. So unless then people will start having their own uninterruptible power supply, and everybody will install battery in their own office, and then put UPS, those uninterruptible power supply. So you get into all sorts of problems. Some countries like India has all these problems. Even Philippines, because in the early years of Marcos, energy was the most corrupt, one of the most corrupt, because it's a very huge budget and people can just corrupt some money, squeeze some money out and put in their own pocket. So the president actually get rid of this energy ministry, and then they went into an energy problem because there's not enough energy. Nobody look at the energy. So corruption actually helps produce energy, because the more energy you produce, the more money you can corrupt. But without corruption, then nobody produce energy already. And then end up the whole country get into trouble, because you get brown out and then black out, and then more and more often brown out, and then you are in trouble. In Singapore, we will face a different problem. We will have too much solar energy. Over time, you'll find they start constructing more and more solar energy and in more creative ways. And the solar energy panel are getting more efficient. So for the same floor area, you can actually get more energy. But this solar panel is almost reaching its theoretical limit already. Its limit is about 35%, but we are reaching like 30%. For the more expensive one, the cheap one maybe is only 20%. But new technology in solar panel may bring it above. And then now they are talking about multi-layer panels. So you may get a lot more energy out of it. So for the same floor area, you get more energy. And Singapore may reach this curve where the solar energy meets or exceed the demand. And then the power station will be in trouble. And this power station, they cannot just switch off and say, oh, there's no demand, I switch off my generator. Cannot. You still got to run it. It's not easy to switch off and start again. Okay, so for this, Okay, we'll end this talk. Thank you.